Hello, we're doing checkpoint 4.31. They give us a function f of xy is equal to x squared minus 2xy plus 5y squared plus 3x minus 2y plus 4, and they want us to find the tangent line to the curve at the point 1, 1. The curve given by the level curve, and the level curve corresponds to when the function is set equal to 8. And then they want us to draw the gradient vector and the tangent vector along with the graph. So correction, it actually should not be 8, it should be 9. That's because if we put 1, 1 into the function, we don't get 8, we actually get a 9 out of that. So if you were to graph the level curve at 8, you'll see that the point 1, 1 is not on that level curve and therefore will not work for us. So we want to make sure that a level curve is at 9. So our graph will be looking at the implicit graph, implicit relation between x and y, where x squared minus 2xy plus 5y squared plus 3x minus 2y plus 4 is equal to 9. We didn't really study this in detail. I think there was one checkpoint example that we might have done where we have an x squared and a y squared, so it looks like it's going, and they're both positive, so it looks like in 2 dimensions and conic sections this is going to be an ellipse. But unfortunately there's this extra term here that has a 2xy, and that term will actually make this an ellipse that's been kind of rotated by some angle. And so I think going through the process of trying to figure that out and how that works out, it's a little too difficult. So you can just graph it in Desmos, type it in the way it is written up on the board, and then you'll see how the graph should actually look like. Okay, and actually maybe we can draw the graph now. We have the x and y, so I'm not even sure exactly where the center point is. All I know is that we have the point 1, 1 right here, and the level curve at 9 will give us a graph that kind of looks like like I said, a slanted ellipse. Okay. And then so we want to find the equation of the tangent line, and then we want to graph our vector, our gradient. So the tangent line, for the tangent line we will need slope. We'll need slope. And the slope that we're going to use is dx dy, or dy over dx. It's our usual slope back from our Calculus 1 days, differential calculus days. But we're going to look at this. Back in calculus we would use implicit differentiation, but for us today we're going to use the implicit function theorem, which says that this is actually equal to the negative the partial of f with respect to x and the partial of f with respect to y. Okay, so that's the implicit function theorem. And then after that we're going to evaluate this at the point 1, 1 to get our actual slope. All right, let's find it. The derivative with respect to x is going to be 2x minus 2y minus 2. Let's check that again. 2x minus 2y. Oops, let's call it a plus 3 because we're taking the derivative with respect to x. Okay, so that's the numerator. The denominator is with respect to y, and we get a negative 2x plus 10y minus 2. And don't forget the negative sign. This is supposed to be a negative. And this is what we would have, except we want to evaluate this at the point 1, 1. And so I'll use the vertical bar and saying we're going to put 1, 1 in there. So if we put 1, 1, we're going to get a 2 minus 2 plus 3. And then if we put a 1, 1, you get a negative 2 plus 10. That's negative 8 minus 2 is negative 6. So this is going to be a negative 1/2. So the slope looks like it'll be not so steep, 1/2. And we can find the equation of that line. We have the slope, we just need the point, 0.11. So we have y minus 1 is equal to the slope, x minus 1. You can leave it like that, or you can write it in point slope form. Okay, now let's find the vector, the gradient. So to get the gradient, we're going to simply take our derivatives and then we're going to evaluate it at 1, 1, which we kind of did already. The first one is the gradient with respect to x, and the second one's gradient with respect to, the derivative with respect to x. The second one's the denominator's the derivative with respect to y. So we have our information here already. Oh, I'm sorry. The negative that I got here, if you're wondering, this is negative, and I put this negative down in the 6, but that should have been up here. So maybe let me write this a little bit neater. So this is equals negative here, and the actual gradient or the actual derivative was a positive 6. But we get a negative 1/2 because of the negative sign here. So in other words, our fx is actually 3 positive, and our fy is actually 6, again positive. So this is our gradient. And our gradient would be from here 3 units and then 6 units up. And one thing that we know, because of some facts that we took a look at, is that the gradient is going to be perpendicular to the tangent line of the level curve. Okay, all right, that's it. I hope that helps.